In the last course, you just learned about the concepts of artificial intelligence, machine learning, and neural network. And you also learned about some details of logistic regressions and how we can stack a few logistic regressions together and form neural network. And then you also have a chance to build your neural network and have an additional practice on classifying image. However, there are some techniques that I have not covered them in details so far. Therefore, in this course, I will cover some additional techniques in details so that you can build your models in a systematic manner. Let's get started. Throughout this course, we will continue to use sequential models, which is a very simple tool for constructing a neural network. This is a high-level API of TensorFlow 2, and it's focused on solving the machine learning problems and also focused on the modern deep learning. The core data structure of Keras are layers and models, and the simplest types of model is the sequential models, which is a linear stack of layers. And for more complex architectures, we need to use the functional API. And later on, we will also cover this functional API in other courses. A sequential model is appropriate for a plain stack of layers, which means that each layer has exactly one input tensor and one output tensor. And they are not appropriate when your model has multiple inputs or multiple outputs, or your layers have multiple inputs or multiple outputs, or if you would like to do a layer sharing, or you want to have some nonlinear topologies, that means sequential model is not useful for that. And in that case, we need to use the Keras functional API. There are two ways that we can set up the sequential model. One way is to pass a list of layers to the sequential constructor, and the other way is to use the .add methods to incrementally set up the layer. Let's have an example. First, we import the sequential model, and we also import the dense layer from the tensor.keras models and the TensorFlow.keras layers, respectively. Let's run this out. And in this case, just like what I mentioned, we can pass a list to this sequential constructor and to build the sequential model. This is one of the ways to do that. And the other way is to use the .add functions to sequentially add the layers to these sequential object models. And this is the way that we do it. So they are very similar because in this case, we pass the first item on this list as the first layer, and then the second item on this list as the second layer. Just similar to this, we create a sequential object, and then we edit layer by layer. So you can see that the parameters, the output shapes, and the layers types are all the same in these two methods. In some cases, we might want to separate the activation layers, and Keras also allow us to add the activations layers separately. Now, although the architecture is a little bit different, the models and functions are always the same. Let's take a look on the example. Now we just import one more things from the Keras.layers, that is the activations layers. So let me run this out. And again, we can use the leads to create the models, or we can use the .add functions to create the model. Now you can see the first list item is just a dense layer, and the second item is the activation function, followed by this layer. And then we add in other layers, and then we add in other activation functions, and follows this dense layer. Again, we can use the .add methods to do so. The first thing that we want to do is to add a dense layer, and then followed by an activation layer, and then another dense layer, and followed by the final activations output. Now, if I run the cell, this is the first way we can do that. We try to construct it with a list. And on the other hand, we can use the .f functions to create this new network. In this case, we do not embed the activation layers into the dense layer. And we try to make it a separated activations layer. Just like what I mentioned before, the only difference is the architecture. However, the model and the functions are always the same. Because you can see that there's no parameters in the activation functions. In that case, it does not learn anything from this activation layer. The learnings still happens in the dense layer. As you can see, they have the parameters only in the dense layer. Just a very short remark to let you know what is an activation functions. It helps to decide whether a neuron should be activated or not. That means it will help decide whether the neuron's input to the network is important or not in terms of the training process. Therefore, the key roles of an activation function is to derive the output from a set of the input fed to a node. This is a very quick recap on Keras sequential models, and we will use these methods throughout this course. In the next lesson, I will show you some basic attributes of sequential models. See you in the next video. Bye-bye.